Previously, I mentioned that I'd show you a practical application for a void function. We're going to do that in this video. So first, take a look at the program in front of you. I have two variables, number 1 and number 2. They have the values 13 and 12 respectively. And then I write them out just to show what their values are. We'll use those cout statements in a minute. What if I wanted to exchange the values in the two variables so that number 1 had the value 12 and number 2 had the value 13? How do you do that? Well, the process of exchanging values such as that is called a swap. And you have to have a third variable to perform a swap, because without the third variable, if I assign the value of number 2 to number 1, then I lose the value of number 1 because it's been reassigned with the value number 2. So now I have both variables with the value of 12. So the way I'd perform the swap using a third variable is to introduce a temporary variable, commonly called temp, and assign it the value of the first variable, number 1. Then I can take the value of number 2 and assign it to number 1, and then put the value of temp into the variable number 2. And then we can write out the two values to make sure the swap occurred. Let's build and run the program. And there we go. Number 1 had the value 13 and number 2 had the value 12, and then we swapped them so that number 1 is 12 and number 2 is 13. In a program that sorts data, either alphabetically or numerically, you're going to have to perform this swapping operation many times. So what you want is a function to perform that swap. And the function that performs that swap cannot be a value returning function because we're working with two values, the value in number 1 and the value in number 2. So we have to do it in a void function, but there's still some problems with that. But I'm getting ahead of myself a little bit. Let's start out by writing the void function swap. So we start out with the keyword void, followed by the name of the function swap. It's going to take two parameters, two numbers, and then it's going to use the same technique we used in the program below. We introduce a third variable, temp, assign it the value of the first parameter, and then assign the value of num2 into num1, and then assign the value of temp into num2. And that's all we have to do for the function. So right here, where I have the swap code in the main program, I can replace that with the swap function. And now let's run the program. Build and run. Whoops, something happened. The values did not change. They didn't change because by design, when we pass data into a function, what actually gets passed are copies of the data values that are the parameters. And by copies, I mean that literally a copy is made in memory of the value that's stored in the variable, and that is used for the data values that are passed into the function. So when you look at the function call in the main program, I've highlighted the arguments number 1 and number 2. Those are actually copies of the values 13 and 12. So that in the function, while those values are swapped, when we come back to the main program, the values that are in number 1, right there, hard to highlight just one, in this number 1, and the value that's in number 2 are not changed because the compiler is still looking at the memory location where the original value was stored. So what do we do about that? Well, there's a very simple solution. The solution is to rewrite the swap function so that instead of using what we're going to call pass by value parameters, that's what it's called when copies of values are used in a function, pass by value. We're going to use reference parameters and pass those parameters by reference. Now, a reference is a direct link to the memory location that stores the value of the variable. So rather than passing copies, we're passing links to the memory locations themselves, what are called references. That's the only change we need to make to the function, so let's run it and see what happens. There we go. Number 1 was 13, and now it's 12. Number 2 was 12, and now it's 13. The reference operator is the ampersand, and it can be placed either in front of the variable, like I did here, or right in front of the data type. Either way works. That's just a syntactical issue, doesn't really change anything. I'll run it again just so you can see that there's no difference in the program. This concept of pass by reference is important because there are situations, such as the swap function, when you need to be able to change the values of the data passed into a function. Many times you don't want the values being passed into a function to change, but in situations such as a swap, you need those values to change, and when you do that, you need to use reference parameters.